Sir, good evening, sir. Sir, good evening.
Yes, ma'am. Good evening, ma'am.
Sir, start the session, sir.
Yeah, thank you.
Thank you, sir.
Good evening, all of you. This is Vijay Babu, GATE faculty. I'm in this field more than 10 years. And for the encouragement of students and to encourage many, I have been writing examinations. And I cleared the examination 6 times. And I feel that everybody who is really having the passion with the dedication, they are going to clear the examination. So this evening, I'm going to take a algorithm subject for you. This is one of the core subjects of the computer science, as all of you know about this. So let me start this session with the syllabus. Is my voice audible to all of you? Is my voice audible to all of you?
Yes, sir.
Yeah, thank you. So this is the syllabus, and yeah, I'm going to share my screen also now. So this is the syllabus, algorithms. So as all of you are familiar with this subject, I think all of you are second years, I think. Yeah.
Yes, sir.
Yeah. So don't worry, I'm going to teach the subjects right from the basics. We are going to learn subject in detail, in depth. So algorithms. So here we are having the topics like searching, sorting, hashing, asymptotic worst case time and space complexities, and algorithm design techniques, greedy method, dynamic programming, divide and conquer. So these are the design techniques. And graph search, minimum spanning trees, shortest paths. So these are the things which are there in our syllabus. So usually the searching like a linear search or sequential search and a binary search. So this is the area, is a focused area only. So whenever the question comes, it comes around the 1 or 2 marks. So it always it's focusing on what is the time complexity, what is the space complexity, what will be the recurrence relation, so and comparisons, all these things. So that is about the weightage. I'm coming to this one, sorting techniques. So as we all of you know about there are major and minor sorting techniques we are having. So here the sorting techniques, we are going to cover all the sorting techniques. It is no, so minimum is 1 mark and maximum 4 marks. Like a linked questions like that, it is giving the weightage is like this. So whereas coming to the hashing, it is also one of the most important areas. So it is giving something like 1 mark, and is coming in the for 4 marks also, and sorry, 2 marks, or else it's 4 marks. Like that, the questions are coming in this area. And coming to the asymptotic worst case, asymptotic notations, whatever the notations it is, big O notation, theta notation, omega notations. So like the notations that we are going to represent use as part of mentioning the time complexity and the space complexity. So here it is coming. No, this is every year you are going to get the question from this area. So it is also from 1 mark, sometimes 2 marks, sometimes 4 marks. So this is greedy method and design techniques. So this is a weightage is 2 marks, and it is a weightage is sometimes 2 marks, or let's say 4 to 4 marks. So divide and conquer, and it is also 2 marks, either 4 marks. Graph traversals, it is also Sometimes it is 1 mark, 2 marks, like that. And minimum spanning trees is a very, very important area once again. So it is coming either 2 marks or 4 marks. Shortest paths, it is 1 mark or 2 marks, like that. So every area is almost covered in this. So this is the portion of the algorithms, the syllabus of the algorithm, right? So I encourage you that if you learn this subject in detail, in depth, you're going to build you will be having confidence. So I feel most of you know that the qualifying marks out of 100, sometimes it is 25 marks, sometimes it's 30 marks, sometimes it's 32 marks, like that. So if you really want to clear the GATE examination with the good scores, I encourage you people have to study more than 6 subjects. So that is I encourage you to have the complete idea about this subject. Now, just I'm sharing the whiteboard. Yeah, thanks for your patience. I think my whiteboard is visible to all of you. Sorry.
Yes, sir.
Yeah. Thank you. So let us start this session from the basic fundamentals, and let us learn the things one after another. And if you have doubts or queries, whatever it is, welcome. And please you can ask me. You can use the chat box also. Fine. So the subject, the name itself is an algorithm. The name of the algorithm came from the name of the Persian author, whose name is Abu Jafar Muhammad ibn Muzzal. He has written some textbooks on the mathematics. He written a textbook on mathematics. So he's the one who really proposed that the concept of algorithms. The name algorithm came from his name only. So now let us come to the definition part of the algorithm. Right. So most of you are aware of the algorithm according to your textbooks. I know your textbook, Anani Loniton, is design and analysis of algorithm. So according to there are many definitions about the algorithm. Definitely, we can say that algorithm is a sequence of unambiguous instructions for solving a problem. That is, for obtaining an output for any legitimate input in a finite amount of time. So that is a definition from your textbook. So, and it is also defined like the algorithm. It is a method of solving a problem simply, and it is a step-by-step process to solve the given problem, or algorithm set of well-ordered instructions in order to accomplish the given task. So there are different definitions from the different textbooks. Whatever the definition it is, so it has to satisfy the properties or the criteria of the algorithm. It has to satisfy the criteria of the algorithm. So let me say that. So according to your textbooks, right? It is a sequence of well-ordered instructions in order to accomplish the given task. That is a simple definition about the algorithm. Now we need to have the idea about the criteria, right? So one is about the input, second one is about the output, third one is about the definiteness, fourth one finiteness, fifth one effectiveness. So this is the criteria of the algorithm. These are the properties of algorithm, what I mean to say. So if anyone want to describe or define about the algorithm, so this criteria has to be satisfied. So first one, it is an input. So input, algorithm may take 0 quantities or more quantity of input. So input which is given to the algorithm, it really plays a vital role. What kind of input you are giving, according to the algorithm, whether you are giving a correct input or not. The input should be the range should be defined, and the input, either a 0 or more number of inputs has to be taken into the consideration. Coming to the output, so algorithm has to give at least one output. So that is the criteria of the from the output side. Coming to the definiteness, definiteness. Here, every instruction should be very clear and easy to understand. So it should be simple without having any ambiguity. So that's why it's unambiguous. It should be simple and unambiguous. So finiteness. Coming to this. So after the finite number of steps, after the finite number of instructions, algorithm should be terminated, and it has to generate an output. So it should not go into the infinite loop. Or after taking the legitimate input, after the finite number of steps, it has to terminate and give an output. That is about the finiteness. Coming to the effectiveness. The effectiveness of algorithm is nothing but every instruction should be very basic and easy to carry out. So that is about the effectiveness of algorithm. So these are the properties or criteria of the algorithm. So every algorithm has to be if you want to want to define something about algorithm, so these are the 5 things has to be satisfied. That's why we are saying this is a criteria of the algorithm. So that is about the definition of the algorithm. And now the notion of the algorithm. So there is a problem. For the problem, we design an algorithm. The algorithm is taken in the form of a program the computer takes. So taking an input, computer, so it is having a program. So program means, most of you know that what is a program also. So can I hear about the program? How can you define a program? Or otherwise, we can say, what is the difference between the algorithm and program? Anyone, please. Fine. I will tell you the program. So program also we can define something like a sequence of well-ordered instructions in order to accomplish the given task. For algorithm also giving the same definition, but what is the difference between these two? So algorithm, it is not we are not using a programming language to write an algorithm. So for the program, we are using the programming language, either C or C++, Java, whatever it is. So the program, which is a machine understandable way, we are writing the, and algorithm, it is a human understandable way. So the problem, for the problem, there is an algorithm, so designed. So many design techniques are there. We can design the algorithm. We are going to learn things one after another. So when the algorithm is taken into the computer, when it is taking an input, it has to generate an output. So as we have just discussed, the five things regarding the criteria of the algorithm: input, output, definiteness, finiteness, and effectiveness. So all these things are considered in the according to the concept of the algorithm. And here, the important things that we need to understand regarding this. So every instruction, every step of the algorithm should be simple without having any ambiguity. So non-ambiguity, that is the thing we have to consider. And when you're giving the input, so the range of input should be carefully considered. So that is about when you're taking the input to the algorithm. And there may exist several algorithms for solving the same problem, right? We have a problem. So problem may be a minor problem or major problem, whatever it is. So there are different wide variety of algorithms in order to solve the same problem. So that kind of facility is there. And algorithm for the same problem, it can be based on very different ideas also. So that is also taken into the consideration. It can solve the problem with dramatically different speeds. The ideas which are very, very important regarding that one. So ideas in the sense, sometimes it may be when we are designing an algorithm. So the space complexity, the time complexity, the number of instructions in the algorithm, simplification of the unnecessary loops or common sub-expressions. So sometimes reducing the cost, everything will be considered in this regard. So there may exist several algorithms for solving. Sorry, thanks for conveying this. Is it okay now? Yeah. Huh? Yeah, thank you. So now, so these are the things that I mentioned now. So there should be non-ambiguity, so and simplicity of each and every instruction of the algorithm, and the input when you're taking a input for the algorithm. So the range of inputs has to be specified carefully, and for the problem, for the given problem, there may exist multiple algorithms. So the same algorithm can be represented in several different ways also. So I will show it. This is the one problem. Problem has algorithm 1, algorithm 2, algorithm 3. Likewise, wide variety of algorithms we can design for that one. So we will see one after another. And the ideas are very useful regarding when we analyze the algorithm, in the sense, sometimes the cost of the operations, sometimes the common sub-expression elimination, sometimes it is space complexity, sometimes the time complexity. Everything will be considered when we design an algorithm and analyze that an algorithm. So these are the things regarding the important things when we focusing on the notion of the algorithm, right? So now, when we are going for algorithm, so let me show things regarding the algorithm, and so and the specification, how you are going to specify an algorithm. So algorithm can be represented in wide variety of ranges, or wide variety of ways also. So algorithm can be represented in the form of a flow chart. Algorithm can be represented in the form of a pseudocode. Algorithm can be represented in the with the natural language also. So there are different ways to represent an algorithm, right? If you are going for this kind of thing, we have to understand how the algorithm is going to be represented. So I will show you, and let me say something about the flow chart. So it is a pictorial representation of an algorithm. So for a given problem, we are going to design algorithm. That algorithm is going to be represented in the form of a flow chart. So it is having some symbols and no, so things like uh, I will show you with an example. Here the terminal symbol, input output symbol, process and flow direction, annotation, and decision making, connectors, predefined process. All these things are the different things we are going to see with the flow chart. And coming to this pseudocode, the pseudocode is nothing but it's a false code. Pseudocode is nothing but a false code. Pseudocode, it seems to be like a program, but it is not actually a program. So pseudocode is, thank you. So programmer feels easy. So flowchart is it is a pictorial or graphical representation of an algorithm. As a pseudocode is the code which is used to represent an algorithm. So the programmer feels easy to write a program. So it seems to be like a code, but pseudo, the name itself is a false. So the meaning itself is a false code. It seems to be like a program, but it is not a program. But it is a programmer friendly code. That's the thing. All your textbooks, when you go through this, so majority of the algorithm is written in the form of a pseudo code only. And natural language. So with the simple English also, we can write an algorithm. I will show you a simple example how things are represented here. And let me share the screen. Hmm? Yeah. Is my screen is visible to all of you? So just I'm showing a simple algorithm with written in the form of a natural language. So it's a sum of n natural numbers algorithm. So it is having the 9 steps, and that is represented in the form of a flow chart, and also it is represented in the form of uh, C code. So here we can see that sum of n natural numbers, right? So algorithm. So if he has seen that the first step, it is a start followed by the read number, count is equal to 0, sum is equal to 0, count is equal to count plus 1, sum is equal to sum plus count, repeat steps 5 and 6 until count greater than n, print sum, stop. These are the 9 steps that we can see in the algorithm. And coming to that, this one, so here we are having pictorial representation of an algorithm that is nothing but a flow chart. So here we can see that start symbol, right? So for the begin and stop, we are using the same symbol, and followed by the parallelogram, that is a reading. This is a reading, and reading the number here. So, and this is a count is equal to 0 and sum is equal to 0. And this is the process that we can see is one after another. Count is equal to count plus I, sum is equal to sum plus count, is count greater than n. This is for the sake of the decision making. If it is yes, arrow goes like that. If it is no, arrows goes like that. And writing, that is nothing but a display or printing, whatever it is. So printing the things, and finally it is finished. So we can also see that program is C code. This is a simple, very, very simple code that I presented here. So in order to save the time only, I have written like this. And now we can see the concepts of the algorithm. Yeah. Now, let me give one simple example regarding this. So the name, it starts with an algorithm. So, and if simply we're taking some, then my name of an algorithm is something like exchange. So exchange the values. So here, using some temporary variable, sending the value of a, and taking the value a is equal to b. So value of b is copied into a, assigned to a. Temporary. So this is a simple example for the algorithms, just exchanging the values of a and b. So this is the head part, and this is the body, so which is placed in the braces. And here we have seen that this is the note step 1, 2, 3, and displaying values of a and b. So now the simple algorithm we can write like this: the algorithm with the head section followed by the body section. So algorithm is consist of head and body, and we are going to use almost all the syntax of the programming language, like a constructive statements, like a conditional, unconditional, or a looping, or something like operators and symbols. What are the things which we are using in C and C++ Java? We are going to use all these things. So this is regarding the simple example of an algorithm. And algorithm, when you are doing this one, we have to understand the the pseudocode. Just now I mentioned that pseudocode is nothing but it's a false code. It is a user friendly. So otherwise, the programmer feels easy to write a program. So by looking at the algorithm. So now, so when we are going for the algorithm concepts, as we have seen already, what is a properties of an algorithm? A simple example for an algorithm. Now, algorithm, how we are going to represent? Just we have seen that algorithm can be represented with the help of a flowchart. It can be represented in the form of pseudocode. It can be represented in the form of a English-like language also. So when we are doing all these things, we have to consider that algorithms can be represented in the wide variety of ways also. So there is a way to represent an algorithm that is nothing but a recursion also. So we know in the previous section also we have the criteria about the algorithm, like so I have mentioned that 5 things. Now when you're learning the things about the algorithm, we have to understand so how we are representing an algorithm. Now, for example, if I'm doing the factorial of a given number, so you people already know about all these things. I'm going to explain all these things with the simple examples to complex examples. And here I'm writing an algorithm. This algorithm is for finding out a factorial. So factorial of the given number, if I want to find out, so simply I'm saying something like this. I'm using a variable fact. For I is equal to 1 to n, do. Fact is equal to fact or I. Finally, return the value of let me write one more algorithm so that we can understand. What is the difference between non-recursion and recursion? If n is equal to 0, then return 1. else, and n star factor of n. Yeah. So I have written the program, the algorithm. So it's programmer feels easy to write a program from the algorithm, as I mentioned here. The two algorithms. This is a non-recursive one. This is a recursive one. Here, by looking these two things, the algorithm, the non-recursive one, which is we are taking how many statements here. So this is 1, this is 2, this is 3, and this is 4. So these are the statements that we have mentioned in this. And when you come to the algorithm, fact, a recursive function, a recursive algorithm. So when you are considering this one, if n is equal to 0, then return 1, else return n multiplied with the fact of n. So there is a powerful way to represent an algorithm with the help of a recursion. So we, as you have already know in the first year itself, there is a recursion, the direct recursion and indirect recursion, tail recursion, multiple things are there. So thing is here, as I mentioned in the beginning, there are different ways that we can represent an algorithm, and there are different ideas that we have to consider about the algorithms. So whenever we design the algorithm, we consider that, so this is an algorithm, how many variables here it used. So fact is one variable, I is the another variable, n is another variable. So these are the variables that here used. Yeah, sorry, you're correct. So when I'm presenting the things, sorry, by mistake it is a n I have written. So it's a factor of n minus 1 only. So here, when you are looking this, a simple example, we can understand that we can write an algorithm. So recursive algorithm, non-recursive algorithm. So there we are going to see the things regarding that, how many number of statements it is having, how many operations it is performing, what is the time complexity of this one, what is the space complexity of this one. We can able to find out all these things regarding the non-recursive way and recursive way. These are the things that we are going to learn. And when you are going for algorithm, like designing an algorithm, there are different design strategies that we are going to use. How we are going to design an algorithm, how we are going to analyze an algorithm. These are the areas that we are supposed to focus on. Is my screen is visible to all of you? So fine. So when you're designing an algorithm, analyzing an algorithm, there are some process we have to undergo. So that process, we can see that thing here. It is understanding this is the entire process. As a first step, we need to understand the problem. The problem has to understand when there is a problem, simple factorial or simple addition or finding out the GCD or performing some sorting or searching, whatever it is. The problem need to be understand very clearly. Okay. So when we are taking the problem into the consideration, so we need to raise a multiple queries and doubts. So when we raise the multiple queries and doubts, then only we are going to understand the problem clearly. And whenever we are taking the problem, the solution. So simple example we have to consider regarding that. And finally what we are conclude is this is the way to understand the problem. And after the so many queries and doubts also, we are able to understand the problem. So when we understand the problem, then only we can design the solution for the problem. So that is about the understanding the problem. Coming to the second one, that is a computational means. So decide on the computational means. So sometimes, some scientific applications need so large amount of memory space, a large amount of uh, processor, the large amount of memory space, and the faster execution is needed. So that is the thing regarding the computational means. Now all our systems are multi-process systems, or we are having the sufficient memory. That is not an issue for us. And if we are going for real-time applications, then computational means really matters. And there is an exact versus approximate solutions. There are, in the sense, there are some approaches are there. So exact approach and like exact algorithms for the given problem. So it gives exact answers. And so sometimes approximate solutions are also there. For example, if you take the definite integrals, quadratic equations, square root and cube root, for all these things, sometimes it may not give the exact answer solution. So sometimes it's a approximate solution only, but it is very near to that. So there should be a range. So that should be decided regarding that one also. And algorithm design technique, there are wide variety of algorithm design techniques which are available for us. So, and because of if there is a problem, which technique is applicable to solve the problem, so we can see accordingly we can do it. And if you are applying a technique, so it comes under which class, and study about that. All these things are happening with the help of the algorithm design technique. And whereas coming to the design and algorithm, so here the algorithm plus a data structure, it gives it says something like a program. So there are wide variety of algorithms. So sometimes one algorithm may be useful, sometimes another algorithm may be useful, sometimes the combination of algorithms are needed. So like that, so the algorithm with the data structures, as we know that we have the linear data structures and non-linear data structures, all these things are there. So these data structures for solving the given problem. So like a linear data structure stack, a queue, linked list, all these things we know, and as well as a non-linear data structures, trees and graphs, all these things are there. So we should be careful enough to choose a right data structure for the given algorithm in order to solve the given problem. So so that's why finally the algorithm with the plus data structure is equal to program. So finally we are going to write a program for that one. So that is the thing. The designing algorithm, we have to consider the data structure. That is the one more important area. And coming to the prove the correctness. So for the legitimate input, the given algorithm, it has to take input, and within a finite amount of time, it has to generate the correct output. For the legitimate input, with the finite amount of time, it has to generate an output, the correct output. So that has to be taken into the consideration. The correctness of the output, correctness is going to be measured. So when you write a program, when you write an algorithm, so that algorithm is not sufficient without having a correct outcome. So it has to generate the correct output. That is the major area. And coming to the analysis of an algorithm, so analyzing an algorithm. So if you are analyzing an algorithm, so there are things which are very important. That is uh, two things are there: the priori analysis, posterior analysis. Priori analysis, before we are making the algorithm into program. So posterior analysis is like a performance measurement after program gets executed. So, but here the analysis of the algorithm is the priori analysis itself. Here, the thing is, it's the how much amount of space needed, how much amount of time needed to run the algorithm to its completion. That is the thing regarding the analyzing an algorithm. So, and most of our syllabus is based upon this step only. That is nothing but analyzing an algorithm. Okay, so this is about the analysis of an algorithm. And coming to that, finally code the algorithm. So we are supposed to write a program code. So based on the programming language, so we have to choose which programming language. So if you are converting the algorithm into a program, so specific programming language we are going to take. So when you are writing that, so after completion of that one, as algorithm is taking an input, so and it is giving an output for every legitimate input. After the finite amount of time, the algorithm has to give an output. So in the similar way, the program code which you developed, it has to give a correct output. And sometimes algorithm may inefficiently uh, written in the form of a program. So many things has to be considered in this. While you're coding the program, you need to understand that whether it is giving the correct output for every instance, for every possible instance. So for every legitimate input, it is giving output or not. So here the thing is, sometimes when you're coding the program also, so for coding algorithm also, we have to consider that the concept of code optimization. So we can reduce the number of instructions sometimes. Really, we can reduce the number of operations also. We can eliminate some common expressions also. So we can optimize the algorithm. So this is also one of the interesting areas of computer science. So this is the entire process of algorithm design and analysis process. So this is things regarding the algorithm. Now, let me come to the concept of analysis part. So analysis, majorly what we are saying is we are analyzing the space, we are analyzing the time. So when it is taking the input and it is giving an output, so we are focusing on the major areas. That is nothing but how much time it takes and how much space it occupies. So this is about the things regarding the space complexity as well as time complexity. So in this session, I'm going to introduce what is the space complexity and what is the time complexity of an algorithm. Like if I'm taking that space complexity, right? So we have wide variety of algorithms are there, and we will be seeing all these things. So what is the space complexity of an algorithm? The amount of memory it needs to run to its completion. The amount of memory it needs to run to its completion. That is a space complexity. So usually memory means instructions. For instructions, we need space, and for the recursive function calls, we need the stack space. For the variables, we need the data space. So that's why it's the total amount of memory it needs to run to its completion. So that is about the space complexity. And what about the time complexity? The amount of computer time it needs to run the completion. The total amount of computer time it needs to run to its completion. So that is the time complexity of an algorithm. So as I mentioned that, so we are having instruction space and stack space and data space. So, and here is also, when you are considering the time, the two types of things we have has to consider. That is a compilation time and runtime. So majorly, once the program is successfully compiled, no need to compile once again. That's why our focus is on runtime. So when you're coming across the concepts of the analyzing an algorithm, now initially we are starting with the space complexity of an algorithm. So space complexity of an algorithm, which can be represented like this: S of P is equal to C plus SP. So what is this C? C is nothing but a constants. What is the SP? Is the instance characteristics. So space complexity of an algorithm is a combination of two things we have to consider: the total space it is required to run its for the completion of the execution. As we are considered this one, we have two things to consider into the under the space complexity. One is fixed part, and second one is variable part. So please listen carefully. Now the fixed part, it's a as we are mentioning that as S of P is equal to C plus SP. So fixed part is a something, it's a constant, right? And it won't depend upon anything. So when you're considering that fixed part, independent of characteristics of input and outputs. So it is independent. So it's a independent of characteristics of input and output. Space for a simple variables and fixed size component variables like aggregate variables, space for constant, and so on. All these things comes under the fixed part. So coming to the variable part, the variable part, it consists of the space needed by component variables whose size is dependent on a particular problem instance being solved. So here thing is this is dependent. That's the thing where the emphasis part regarding the space complexity we are going to see with an example so that we can understand things clearly. So let me take a simple example so that you can understand what is the space complexity, how to find out the space complexity of an algorithm. For example, if I am taking the algorithm, the name of the algorithm is TYD. And the parameters are X, Y, Z, and W. And here, simply we are returning like this. We know our formula. Simply, it's something like this. It's a constant part, and it is a dependent or is a instance characteristics. So we will be seeing this one here. As a we have consideration about the data. So X, Y, Z, and W. How many variables we are having? 4 variables we are having. So it is returning what? Some value. X star Y plus something Z plus W multiplied with 2.0 plus Z by 3.5. So this is something like a floating point number, and the variables that we have seen as a 4 variables. So X, comma Y, comma Z, comma W. So these are the variables that we have seen here. And if for every variable, so if we say that this is 1 word of memory is required, or one unit amount of time is required. Sorry, one memory word is required, or 1 unit memory is required. So here 2.0 based on the programming language that we are going to use. So we can say that so for 4 variables for X 1 word, Y 1 word, Z 1 word, W 1 word. So there is 4 words of memory is needed. So or otherwise 4 units of memory is needed. So in order to solve this one, so this is only the C part. So the instance characteristics, it is not applicable here because it is not, there is no concept of instance characteristics here. So only the constant part is there. So all together we are going to return the value, that's all. So how many variables that we are using, so their capacities that we consider here. And whereas if we consider an example like this algorithm, sum a comma n. So here a variable taking 0.0 for I is equal to 1 to n, do s is equal to s plus a of I, return s. Right. So this is another example. Now by looking this one, we can understand what is this A. A is nothing but an array. What is this n? This n is the size of the array. So So what it is going to return finally? Sum of elements of the array. So S is equal to initially 0 or 0.0. So it is taking a floating point number. So for I is equal to 1 to n, do S is equal to S plus A of I and return S. So by looking this, we can understand one thing. So how many variables it is having. So otherwise we have S of P is equal to C plus SP. Okay. Now this is a constant. It is a fixed part and it is a variable part. So what is this fixed part and what are the things that we have to consider under this fixed part? Now if I take the variable n, I, yes. So for this one unit is required, for this one n unit, 1 unit is required, and for this one also 1 unit is required. Whereas coming to that variable, so A of I, A is there. So here mentioning simply A of I. So what is the size of an array? Size of an array is dependent on some more thing is, one more thing is there. What is that? That is nothing but n. So if it is takes one word for all these things, so array, a list of elements are there. So here we are taking the floating point numbers only, and it is going to have the size n. So what you're going to finally say about this one? So the instance characteristic here we can see clearly. So this variable is depend upon another variable that is nothing but n. So it is all these are independent one. This is a dependent one. So finally, how much amount of memory is needed? So here for NIS, 3 words of memory, 3 units of memory is sufficient. Whereas coming to this SP, it needs n units of that is a array of size n. So the space complexity of this algorithm, the space required for this one, n 3 plus n words of memory or units of memory, which is required there. And if we take algorithm, this algorithm, recursive algorithm, the same algorithm we are writing in the form of a recursion. So this is the algorithm here. This is a non-recursive algorithm. Array has a list of elements are there. Right. So array, the I starts with 1 to n. So n, it has 4. So initially S is initialized with 0. S is equal to S plus A of I. So like initially is S0 and afterwards S is equal to 0 plus 10. Let me take the some number like 10.5. So initially 10.5 and again afterwards S is equal to I gets incremented by 1. It's a 10.5 plus 5, 15.5. And again it goes like 18.5 and 22.5 like that. So here the I 1, 2, 3, 4 like that. So finally returning the value of S. So this is about the simple algorithm. Is a non-recursive algorithm, and here we can see that algorithm. So if n less than or equal to 0, then return 0. Otherwise return sum of a comma n minus 1 plus a of n. So if you take an array like this, we have considered this one. So this is a array A, and size is mentioned as 4, and we are starting with this one. So if n less than or equal to 0, return 0. So this is not the case. We are coming to this r sum of a comma n minus 1. So r sum of a comma, so n is 4, now it becomes 3 plus a of 4. So this one will be considered now. And for this r sum of a3 again, so it is something like r sum of a comma 2 plus a of 3. And for this also something r sum of, okay, r sum of a comma 2. For this one, we are, again it is going to call r sum of a comma 1 and a of 2. And for a comma 1, it is like a comma 0 and a of 1. When it is 0, it is going to return 0. So this is about the thing regarding recursion. So now our focus is on space complexity once again for this recursive function. So this is a fixed part, this is a variable part. So fixed part focusing on variables which are not depend upon anything. So here we can see that what are the variables which are not independent, which are not depend upon anything. Like A is a array which is dependent on n. So initially, let me start with this. Actually, in order to perform this one, the recursion stack is needed for this one. R sum of a comma a comma 3, R sum of a comma 2, R sum of a comma 1, R sum of a comma. Finally, it goes with 1. And when it goes to 0, it is going to return 0. And here thing is, so the recursion a of n, if you take this, so it becomes a of n minus 1. So n to n minus 1. So n minus 1, n minus 2. Likewise, it is going to be having this kind of recursive execution. And here we are going to understand the thing is, so the stack space it is going to use. So recursion stack space, how it is going to utilize that we have to learn in depth and in detail. And for this one, I'm telling you that. So recursion stack space, if you consider, which includes the space for formal parameters, local variables, return address. So in order to compute the value of R sum of A4, when we start with R sum of A4, computer says, so first of all, you go and find out the value of R sum of A3 and then value of R sum of A2. Likewise, so recursion stack space, so something like this. If you consider that, yeah, likewise, now the invocation is going to be happen, the calling the function or sum of A4 and 3 and 2 and 1 and finally it's 0. So when you're getting the final value for that one is going to be taken into the consideration of this one plus adding this and this one and plus adding this and this one plus adding this and this one and plus adding this. Everything is going to be considered. Finally, you're going to get an answer. But here thing is we are using the recursion stack space. So when you're considering these things, it goes for the finally sum of A comma 0. So when n less than or equal to 0, the return value of 0. So finally it takes that and when taking that one and it is going to compute the value of R sum of A comma 1 and afterwards A comma 2 and afterwards A comma 3 and afterwards A comma 4 likewise. So by looking this one, we have to understand one important thing. So S of P is equal to C plus SP. This is a fixed part and this is a variable part. Fixed part, so the variables which are independent. By looking this one, we can understand that N is the variable. So if we take that 1 unit amount of memory is required for N. So that is N. And also we have to consider the things here. This is the part. So if you take this one, as we mentioned that this is a N, 1 unit. And here things are there, something like a written address should be there. And something like a pointer to an array should be there. So for the return address also 1 unit amount of time. For the pointer to arrow is also 1 unit amount of time. So likewise, these are the three things that we have to consider regarding this one here. So for array, referencing that one, so n every time n becomes n minus 1 like that. So it also requires the 1 unit amount of time and the return address. So all the time it is also 1 unit. So totally how many units of memory is needed is a 3 units of memory unit. But we have to understand, so what is the depth of the recursion. So if you take that n, it becomes n minus 1 and n minus 1 again it goes like 4 3 2 1 0 and finally we are going to get the answer consideration into that one. So as we have drawn a tree also now, so here we can see that 4 3 2 1 and again a of 0, right? So if you take that consideration, so finally what we can say about this one is, so n is considered, and the depth of the recursion is going to consider into that. So it is going to decrement it till n value becomes a 0. And finally, if n becomes 0, it is going to return the value of 0. So how many times this is going to be considered, that is based on the depth of the recursion. So here the depth of the recursion is n plus 1. Finally, it is giving that value. So if it is the depth of the recursion, every time we are supposed to use these three things. What are they? N and return address and a pointer to an array. So these are the three. This is 1, this is 1, this is 1. So 3 into n plus 1. This is the thing which is finally what we can say, that the time, the space complexity, not a time complexity, it is a space complexity. So this is order of, again it is n. So why it is 3? Because we are using these 3. And why it is n plus 1? The depth of the recursion is n plus 1. So finally, the space needed for this one is like this, but it can be simply say that order of n also. So whenever you are mentioning the time complexity or space complexity, usually we are using that representation as a big O representation. So n plus 1 is going to be considered as depth of the recursion. And these are the three things. The space needed for the recursive algorithm is like that. And this is a n plus 1. So it is near to the n only. And this is a 3. This is nothing but a constant. So whenever we can omit this, simply it is in terms of n. So it may be a linear bounded, it may be a polynomial bounded, it may be a logarithmically bounded, it may be a exponentially bounded. We have the different types of growths are there. So that we are going to see. And let me go for simple example once again. So where we can find out the time complexity of an algorithm also. So prior to that one, go for the one more example of add of n. So if I take that, result is equal to 0 for I is equal to 1 to n 2. Result is equal to result plus I and return result. So if you consider this algorithm, so please look at this, and this name of the algorithm is add. Again, what we are trying to add over here, just we are the unnatural numbers that we are considering and adding them. So in this algorithm, if I want to find out the space complexity, so what are the things that we have to consider? This is a fixed part and variable part. So till now we have seen that fixed and variable parts, how we have to consider. So here the variable n is there, and the variable result is there, and the variable I is there. So how many variables that we are having? Definitely it is a 3 variables: n, I, result. So if n needs one unit of memory, I needs 1 unit of memory, result needs 1 unit of memory, total is it needs 3 units of memory. So we can say that as SP of this one is 3. Sometimes it is order of n, sometimes it is order of constant, sometimes it is order of n square likewise. So we have to understand what is this and what is this and what is this, right? So if the memory is needed, as we are defining that space complexity of an algorithm, space complexity of algorithm is the amount of space required to run the algorithm to its completion. So if n is considered as an input, the size of an input, so sometimes accordingly we need the memory space. Sometimes n is sufficient, sometimes less than n is sufficient, sometimes greater than n is sufficient, right? So whether twice or thrice, otherwise n into n. So these are the different probabilities that the space complexity is going to be considered. So within the less amount of time are you going to complete, are you going to execute within the same length as it is giving the size of the input, or more than that you're going to consider. That is the thing regarding that one. So space complexity of an algorithm, which considered as we mentioned that instruction space is required, stack space is required, and data space is required. So here we are focusing on the data space as well as the stack space. So in this algorithm, we have seen that there are four variables. So 4 words are 4 units of memory is required, space is required. So here, this is n. Here we could see that. So here the things are 3 plus n. S, I, N. These are the three variables. N, I, S. These are the three variables, and A is a variable. It's a no. It's depend upon the size of the array, that is n. So that's why it's a 3 plus n. So it is a more than n is needed. So what is the thing which we have considered here is the size of the array. What is this? This is the size of the array. In order to execute this algorithm, it requires Sorry, it is disconnected. Now I'm able to reconnect. So today, just we have seen that. So what are the different styles of defining an algorithm and the criteria of the algorithm and the notion of the algorithm, and some important points regarding this, the specification of the algorithm like a flowchart, pseudocode, and with the help of the natural language. And we have seen that what is the space complexity and what is the time complexity, with the simple definitions only. Coming to the space complexity, as we have considered things regarding that fixed part and the variable part, and one is the dependent one and another one is the independent one. This is about the space complexity, how to find out. These are the different examples we have seen. So, to find out the space and complexities of algorithm with instance characteristics like this. So now I'm going to end my class with this. If you have any queries, please try to ask. So tomorrow onwards, we are going to see things a little. Just 1 second. Yeah. So so the So this is our first class, and we have seen that the introduction of about all these algorithm and what is the weightage of all these things we have seen. And if you have any queries, please share so that I'm going to clear it. And before starting the second class also, I'm going to clear all your queries, and we are going to see things in detail. Thank you. Yeah, please. Hello, madam.